Well, we have some time this week to take a closer look at Maven. I'm hoping that you've all by this time watched the video called Java Build Systems that you'll find on my YouTube page. But let's look a little deeper at Maven and then look at that POM file that's so critical to us. So Maven is an Apache project. This means it's an open source tool. You can access the source code. You can even become a contributor to it. And to sum it up, it likes to describe itself as a software project management and comprehension tool, a way to manage all the different pieces and to understand what goes into a particular project. We generally just call it a build tool, and that's what I refer to it all the time, but it can do a lot more. Let me just give you one example. We won't see it today, but I use Maven to transfer files from my PC to my Raspberry Pi and then to execute the code on the Raspberry Pi. That's how much I can do with Maven. So, its primary goal, going back to its original statement, to allow a developer to comprehend the complete state of a development effort in the shortest period of time possible. How to quickly understand what a project is about. You could read the source code, but without an understanding of what libraries and what other components come together, it would be hard to understand what exactly a particular project is about. The Maven POM file can help us with that. So, Maven build. Well, the first thing, and what we've been most excited about, and what you've already used, is the fact that it ensures that the right library jars are in the build path of a project. No more searching for files on the internet, downloading them, and then copying them into our project. Maven takes care of that for us. It manages the compiling and building. Maven executes the Java compiler. Maven executes the necessary tools to create the appropriate archive, whether it's a jar, a war, or an ear. Maven encourages the use of unit testing by giving it the ability to execute the tests whenever a project is built. That's something to keep in mind. Testing is independent from running. That's how we can do some of the things we have been doing using unit tests. With Maven, we're assured that our unit tests will execute every time we build our program. Oh, let me move myself out of the way here. It provides a standard project file structure so that projects can be used in different IDEs. Well, the three big IDEs, of course, are Eclipse, IntelliJ, and NetBeans. Each one of them has their own internal build system and their own internal directory structure, which means that we cannot just take the files and folders from one IDE and open them with another. Maven defines a standard that all three of the major IDEs recognize. So, what does our build system do? Well, first is cleanup. And what cleanup means is to simply delete all the files that were created in the last build. A cleanup will ensure that every source file will be recompiled. Manage dependencies. If a particular library is not available on your local machine, in your local repository, Maven will take it upon itself to download the appropriate library, the dependency that you need. It will compile the source code. That's kind of obvious. It will copy any resources. For example, one resource that you've just started to notice is a little file called log4j.xml. This particular file defines how our logger displays its information. It's considered a resource. It's required by our program when it executes, but it itself is not an executable. We'll learn about a lot more resources, especially when we start working with JavaFX. Run tests. Well, we've already mentioned that. Tests are so critical. Just because something compiles doesn't mean it works. Packaging the product or packaging the project so it's ready for distribution. And in some cases, especially when we're dealing with servers, Maven can also be used to deploy the project to the server. That's kind of like what I'm doing with my Raspberry Pi work, deploying the project to the Raspberry Pi. So the basic architecture, and this is taken from an illustration from the Maven site, says that we have a project we wish to build. That project, by virtue of its POM file, passes into the Maven core, and the Maven core itself is made up of what are called plugins. These are small programs that perform some part of the build process that Maven is responsible for. Maven already is able to compile and package your applications, but there are other tasks that we might like to use. For instance, you've probably seen the Surefire plugin. One of its jobs is to allow you to write the output of your JUnit testing to a file. Here we see an illustration of, the directory structure of Maven. It's important. This is the kind of slide I'd almost say you want to print out and keep somewhere. And that's because in many cases when we start a project with any of the IDEs, whether it's NetBeans or Eclipse or IntelliJ, it may not create the necessary directories that you need. For instance, if we take a look at resources, resources is under source main resources. You usually need to create this folder manually. It's easy to do in NetBeans. We can go to the Files view. If you're using Eclipse, you're going to have to create it with your File tool, File Explorer in Windows, and then Eclipse will recognize that you've added the appropriate folder. Each of these represents something that we need. Well, Java's our source, resources. I'm only going to focus on what we do this term, right? So, Java, resources. Then we have our test, Java and resources. Test is significant because this code is never part of the final package. We do not deliver a product with our test code in it. Resources for test code, again, you might have spotted it already. That's where I store the SQL statements to recreate the databases when I'm using my @before and unit testing. Those are the critical ones that we'll use in this course. Now, when we refer to projects in Maven, we say that everything has its coordinates. The coordinates, as it says, are uniquely identification. Let's move my picture out of the way here. So here they are. We have the group ID. Again, you've seen this already because we had to address this in creating a new project with NetBeans or Eclipse. So the group ID is usually a two-part name. As I said in class, frequently it's an organization's domain backwards. So we all know that I own kenfogel.com, so I usually use as my group ID com.kenfogel. There are no rules here. You're free to come up with anything that hopefully makes sense, and that if someone else is looking at it will understand why you chose what you did for your group ID. Next, the artifact ID. This is usually the name of the project. With some of our tools, and here's something that Eclipse gets right and NetBeans doesn't, if we give an artifact ID with uppercase letters, when NetBeans creates the project structure, it will create a package based on the group ID and the artifact ID, but unfortunately, it will make the artifact ID all lowercase, but record it in the POM file as you typed it, combination of upper and lowercase. And suddenly you have an unusual error, usually tied to not being able to find the main. The easiest way to resolve this particular problem is always enter the artifact ID in lowercase. As a matter of fact, treat it like the rules for packages, which are all lowercase. Next, the version. This is quite important because in situations where we are asking Maven to go off and retrieve a library we don't have, there's a good chance that there are many versions of that library stored in the Maven repositories. We need to know what version we're working with. So for instance, an example, and here we're just diagramming it out, group ID, artifact ID, version. For instance, JUnit. Here's an example of one that doesn't use a reverse domain name. It's simply JUnit. Or here we have somebody's name, though here they've used as the group ID the full domain name. Then included the artifact ID followed by the version number. Another example similar to that. The thing to remember for all three of these is that they're strings, even the version, so they can be anything that we want. You've probably seen the word snapshot. That shows up, that indicates that this particular version is in development. Now, within Maven, we say that we have a build lifecycle. A lifecycle are the actions or steps that are taken by our particular tool. Interestingly, there's only 3 life cycles available to us. First, the default, what we tend to use all the time, and this is what handles building the project, deploying it. Everything that we associate, everything that we've seen Maven do is part of default. We also have the option for clean. Well, as we've seen, clean is a kind of interesting life cycle because all it does is delete all the compiled code, and all that compiled code is always found in a folder called target. You can see that folder in the files view of NetBeans. And then finally site. I have to be honest with you, I've never used this particular life cycle. It's related to dealing with project documentation. Everything that we do will rely on the default cycle, so there'll be nothing we have to do in terms of configuration here. Now, each of the life cycles are themselves broken down into build phases. A build phase is made up of a goal, a particular outcome that we expect. We do use phases and goals. So here we have the default phases for a default life cycle. If we do nothing, if we don't change or indicate particular parts of the cycle, when we ask Maven to build a project, the first thing it's going to do is validate the pom.xml. Make sure that it is valid. It's a verified XML file, and everything is understood. If it passes validation, next it's time to compile the source code. Next is a test. We package it, create our jar, our war, our ear. And finally, we have a verification of the package, or not finally, but next. This is simply a test to make sure that it is a proper zip file. And then install. Though in this case, so let me move this. It says here, publish the package to the local repo. Repo is short for repository. Every time you create a project and you go through the default lifecycle, your project is stored in the repository. What this means is if you build other projects, those other projects can have a Maven dependency on previous work of your own, and it will find these particular files in your repository. And finally, deploy. Now, deploy means that you have privileges in a remote repository that would allow you to store it in one of the major repositories. The most common is called maven.org. Plugins. These are the things that allow us to add features to a Maven build. Plugins are artifacts that provide goals, so they provide additional services above and beyond the default lifecycle. And there's a lot of them out there. Whoops, let's find my mouse here. I guess I'm not going to find it here. It's lost. So, there's a large library of items that you can find and use in your projects. There we go. I've moved myself out of the way. Of course, you can write your own plugins if you're so if you feel that there is some operation that you'd like to make part of Maven. Plugins, well, Maven has to know when they're going to run. And so what we do is we bind a plugin to a particular life cycle so that, a particular phase in that life cycle. Is it going to happen when we clean, when we compile? For instance, the Surefire plugin happens during the test phase of our life cycle. So we can either indicate that the plugin performs at a certain point within the plugin itself, or we can indicate in our POM when this plugin should be active, when it should perform its task. Repositories. Well, this is where the artifacts are stored of, whatever Maven is able to retrieve for us. I should point out that artifacts can be plugins. The very first time you build something with Maven, you're going to see probably 50 or 60 downloads from the repository, all related to just Maven itself. These are simply libraries that Maven needs to execute. They're not going to be part of your program, but Maven needs access to them. Repositories can be local or remote. You can have a repository on your local machine. And of course, that's important because if we download a file from a remote repository, we certainly don't want to have to download it every time we compile our code, we build our code. So when a particular artifact is required, it's brought down and placed in the local repository. As it says here, the local repository is a local cache for quick access to artifacts that you need. There's Maven Central, I mentioned before, maven.org, and in many cases, certain corporations, certain developers maintain their own repositories. And within Maven, we have a particular configuration that allows us to indicate what repositories to search for. By default, Maven Central. Anything else, we add it to the POM. Snapshot builds. There's our word snapshot. It's used to designate that this particular project has not yet been released. So this is not the production version. It ends with -snapshot after the version number. And it's kept separately from other files. It's assumed that something that is a snapshot is not suitable for inclusion in other projects. It's only when it goes from snapshot, actually, as soon as there is no -snapshot, now the project in a repository is suitable for use in other projects. If I had access to a remote repository, I would not be able to put up any projects that had a version number that ended in -snapshot. They would stay strictly in my local repository. Right? Never synchronized with Maven Central. They can be updated. So this is important. Normally when we release a final version of code and it goes into the repository, it is expected that if there are any changes, we're going to get a different version number. However, with Snapshot, it's acceptable to reuse the version number. So, our POM file stands for Project Object Module. It describes our project. That description consists of the name and the version, the artifact type, source code locations if necessary, though when we use Maven within an IDE, these locations are known, but we can add additional locations, any dependencies, any plugins, and profiles. It's possible to write a POM that can handle different types of builds depending on conditions that we set. And the POM is written in XML. So we begin the POM with something called the GAV. And it's called GAV because it consists of, we've seen this already, the group ID, the artifact ID, and the version, hence GAV. And we have a recommendation for naming, but of course you're free to use anything you want. It's probably a good idea when you're working to see what a company standard might be for versioning of your code. So altogether, it's group ID, artifact ID, version. Here we can see a block from a POM file. Technically, this would be about the smallest POM that you could create. Packaging. We need to indicate exactly what type of package we want from our code. It could be a POM. Sounds strange, but it is possible to package POMs for use in other projects. Of course, there's my jar, and a jar represents a Java archive, a WAR, a web archive, and an EAR, an enterprise archive, even create our own. By default, Maven will produce a jar. So here we've added packaging down here to indicate that we want a jar file from this project. Our dependencies. Dependencies are blocks in our POM that indicate the name of a library file, a code that's stored in a repository. When we build a project, Maven will first look for dependencies in your local repository, and if it can't find them, then it will go to the remote repository. So our dependency consists of the GAV, so we have to have a name, but dependencies can also have a scope. For instance, when we do unit testing, we'd say that the JUnit library is test scope. This ensures that it's not going to be included in the project when it's packaged. We have compile. That's the default, and this implies that this particular library will be part of the final jar. And then there's provided. We'll see provided when we start working with application servers, where our program executes on a remote enterprise server, and that enterprise server already has the necessary libraries to use. And finally, the type. We can also indicate what format this dependency is, though in most cases it's going to be a jar, but as you can see, it can be a dependency in any of these categories. So here we see a dependency block. It's MySQL, that's its artifact ID, there's the version number. Scope tells us it's provided. So this means that Maven will not add this library to our code. Now, interestingly, it will go out and retrieve this dependency. This JDBC driver will end up in your local repository because when your code is being compiled, the compiler needs access to this jar. When it's packaged, however, because we've said it's provided, it will not be added to the jar. Here's just a simple illustration that points out that when we're using Maven, we could be dealing with a repository on our own system. We could be using a repository that's available on our local network. This would imply that it's mapped possibly to a drive letter, but it's within our boundaries. And then, of course, the external, the central, Maven Central, or any other repository, and these would be referenced, the external repositories, by their URL. So, one of the neat things about Maven is that it uses the HTTP protocol. The advantage of anything that uses HTTP protocol is the fact that in most organizations, the HTTP port 80 is always open. So you're not confronted with issues of security or firewalls when bringing things down. Those dependencies, as we've said, are cached to the local repository. And oh yes, that local repository is normally found in, well, let's take user home. The actual value here will vary from Linux to Windows. In Windows, it's in users, your login name, and then you'll find .m2. Inside of .m2 is a repository folder, and that's where everything will be placed. The repository itself uses the GAV, uses the version to create a directory structure, so that at the very bottom of this group of directories, we will find our jar. So what we see is the periods that we used in our GAV are replaced with a slash. Not here, this is part of the name, it is a jar, but each of these slashes were periods in the POM file. Maven is the primary repository. If you want to go visit it, there's its URL, and you can search for it manually here if you'd like to find something yourself. This is particularly useful if you know the name of a library, but you don't know what its POM dependency block should look like. Searching for it will show you what you must include in your POM. If you want more information, I recommend you pick up the documentation. There's the reference stuff, which is usually horrible to read, but Sonatype. Sonatype was the original keeper, the original maintainer of Maven. They since turned it over some years ago to Apache. That's why it's called Apache Maven, but they still keep their documentation up to date. They have some great free books, certainly a lot friendlier to read than the actual Maven documentation. Excuse me. And there's also videos that you can watch. Let's look at the POM file that we've been using so far this term. Let's move myself down into this corner, and here we go. As you can see, and I hope you've seen, these are all extensively commented so you can understand what it is. And I think you have to assume that if I commented this is something you need to know. That questions about what's going on here could conceivably end up in an exam. So, every POM file begins with project. This particular block we see here is simply a standard block. There's no variation. What this means, we'll explain a bit more in depth next term. So we begin. The model version. There is only one model version, that's 4.0.0. Now the group ID. As I've said before, typically the reverse domain name. Then the name given to the package build. So here's an example of a potential problem because I've left this in the exact case, capital F and so on. This could be an issue somewhere else in my file. Have to keep an eye on that. Next is my version number. It says snapshot. My packaging, jar. Now we come across some optional fields. So actually, up until version, it was required. Packaging is optional because it defaults to jar. Name, this allows you to create what I call a friendly name for the project. so you can place any string here. How about a description? That's always handy. It's good to know what's going on. And then we have an identifier block. Your ID, so I would hope that you put your student ID, your name, and your email address. And because there can be more than one developer on a project, we can have one block for every developer. This is optional, but I'd like you to use it. Next, the organization, the company you work for. Well, we all work for Dawson. Next comes properties. Think of properties as variables. Variables that we can use somewhere else in our code. In this particular case, we've said that our project is going to be encoded in UTF-8. UTF-8 means Unicode with the first part representing standard ASCII. Next, we need to know where the main class is, because one of the phases in our goals will be to execute our program. And then finally, we have something called shaded. We'll see it as a plugin later on. Its purpose is to indicate that it's our intention to run this jar. In other words, to provide a jar which, if you double-clicked on it, away you go. Next block is the dependencies. I won't go through them all here for you, but you can see that we're using something called SLF for J, logging for Apache, log4j, and so on. There's my JUnit. Notice its scope is test. This ensures that it's not included in the project. Here's my MySQL. Because I don't indicate scope, it defaults to compile, and this file will be part of our jar. There's mail. So these are all the projects or the code we need to include. Next, the build. I have defined the default goals for this project. Every time you do a clean and build of this project, or a build, well, it'll clean, delete everything, it'll compile it, it will package it, and then it will run it. Exec Java allows us to run. We can override these in the IDE. Next, are there any special resources that I need included in the project? This is a slightly older jar, our older POM as I see it. And in this case, we're stating that within source main Java, by default, it's only going to be interested in files that end in .java. But we're saying here that if you find any files that end in fxml, CSS, or PNG, include them in the project. This is a kind of a problem we have with Eclipse. If you're working with NetBeans, this isn't going to be an issue. Because we've declared files as a resource, we now have to point at the standard resource folder and say pick up everything. Within NetBeans, these two blocks are not required, but if this project is expected to work with Eclipse, they are required. Next, my compiler plugin. Here's where I state that I want to use version 1.8. I want all of the syntax checking available to me from the compiler. I want to see warnings. I want to see deprecation. I want to see everything. Shade. Shade is all about creating an executable jar. Shade is what takes your code and changes and adds to the jar file to allow you to double click it. And here we can see that property, $main class. This is information that has to be in my shade package. Next, we have my exec. This is the plugin that will run our program after it's been compiled and packaged. There's our friend Surefire. We've seen Surefire without or including the skip tests and configuration. Here we don't have it, which means that the tests are always run. As you go through my sample code, don't forget to look at the POMs. Don't forget to read the documentation the comments that I've placed. So, that's it for Friday. I'm probably still on a plane somewhere. I'll tell you all the great stories and everything that happened on Tuesday, and we'll also start talking about Java FX when I come back. In the meantime, work on your database. When I come back, I'll give you feedback on your first submission. Don't forget to review things like the properties video, the screencast on my YouTube. Also, you can probably also take a look at the resource bundle screencast. Resource bundles are a specialization of properties, and we're going to need that so that we can internationalize our code. So that's it for me. Thanks, Naz, for looking after the class while I've been away, and I'll see you all next week.